Okay, I'd like to just jump a little bit ahead here in Java, and the idea is to do some problems that some of the more advanced mathematical students might find interesting without getting into a piece of software that is just too complicated for anyone to follow. Okay, what I want to do is write a little Java program that computes two sums. Two series expansions in particular. The one is the series expansion for the function 1 divided by 1 minus x. And the mathematical notation that we use to write that series expansion is we use the summation sign, and we say n goes from 0 to infinity of x to the n. In other words, what this whole thing means here is we take the n equals 0 term as x to the 0, then plus the n equal 1 term, x to the 1, then plus the n equal 2 term, x to the 2, x squared, and so on. So we get x to the 0 plus x to the 1 plus x squared plus x cubed, and on and on and on. And this series will converge provided that the absolute value of x is less than 1. The second series I want to sum is the series expansion for e to the x. That's the sum n goes from 0 to infinity of x to the n divided by n factorial. This one looks like x to the 0 divided by 1 because 0 factorial is defined to be the number 1. And then we have x to the 1 divided by 1 factorial. Remember that the factorial function, n factorial, n exclamation point, n factorial is equal to n times n minus 1 times n minus 2, and on until we get to the last term, which is 1. So we just multiply all these terms together, and that's equal to n factorial. And 1 factorial is equal to 1. Then we add x squared divided by 2 factorial, and that's just 2 times 1, plus x cubed divided by 3 factorial, 3 times 2 times 1, and so on. This series converges for any real value of x right there. So I want to sum or approximate the sum of these two infinite series. And I'm going to do that by doing the sum up to 20. Instead of going to infinity, in both cases, I'm only going to go up to 20. But that should be a pretty close approximation. So I'm going to be doing the sum n goes from 0 to 20 of x to the n, and the sum n goes from 0 to 20 of x to the n over here, x to the n over n factorial. Now, if I do that for the value of x equal to a half, then that should approximately equal to 1 divided by 1 minus 1 half. 1 minus 1 half is a half, and 1 divided by a half is 2. So this series right here should about equal to 2, right? This should be about equal to 2, which I have written right here. This series for x equal to a half should approximately equal e to the 1 half. And if you do this on your calculator, it's about 1.649. So that series should approximately sum to that. So let me write the Java program to do these two sums. Okay, so that's what I have right here. Okay, so I'm going to do these two sums right here. So this is, I put my comment here, recognize this as a block comment. We want to demonstrate the for loop, which is, we haven't talked about for loops yet, so that'll be new here. The for loop to compute the sum of two different series. One series is the sum of x to the n, okay, x to the n, and the other computes the sum x to the n divided by n factorial. Okay, and we're going to call this Java file sum.java. So we do as we've done before. We set up class sum. So everything inside our first set of brackets right in here is going to be in our class sum. Okay, so we set up our public static void just as we have done several times before now. Okay, string args, open and close brackets, parentheses, and then we have this right here sets up what that exercise is, our main part of our program. And I'm going to begin by setting as double precision variables. Okay, so these are not integer variables, double precision variables, n sum, sum2, x, and n fact. Notice that I can write them all on the same line. I don't have to write a separate line to declare each variable as a double precision variable. I write them all together here, separated by commas, and then, of course, I end the statement with a semicolon. And I'm going to set my initial value. I'm going to have two sums. I'll call one sum, and I'll call the other sum2, and I'm going to set the initial values of both sums to be 0. So I do that with these two statements. And then, as I've said, the value of x I'm going to be using to compute the sums is x equal to 0.5. Let me pull that here. Remember, this is going to be a computation for x equal 0.5 here and for x equal to 0.5 there. Okay, so that's what that is all about. Okay, now, and for at least one sum, I'm going to have to compute that n factorial. So I begin by setting n fact equal to 1, because 0 factorial is equal to 1. So I just start off and set n fact equal to 1. Now here is what's new, another new Java command, is the for loop. Now I write the for loop all together here, right in here. I say for, and I say n equals 0, semicolon, n less than 21, semicolon, n plus plus. So what is this doing? Well, I'm running through all the values of n, everything that's inside this set of brackets right here, this set of brackets, everything in there is, what's happening is I'm starting at n equals 0 and going up to n equal 20. So this executes for all values of n between 0 and 20. When n equals 21, this condition here is no longer satisfied because n is no longer less than 21. And the n plus plus statement here, what that means is I start at n equals 0 and I execute everything that's inside here for n equals 0. Then I come back and I increment n by 1. So it goes from n equals 0 to n equal 1. Then I execute everything that's inside here. Okay, and then after I do that, I go back and I set n equal to 2 and execute everything, and I keep going until I get the last one I execute is n equal to 20. So what am I executing here? I'm setting sum equal to sum plus math.pow and then x comma n inside parentheses. So what is this? Well, we've done things like this before when we were programming in BASIC. The idea is that we're going to take the old value of whatever's in sum, we're going to add to it whatever this computation yields to produce the new value of sum. Now this math.pow, okay, what that is this is a class of math functions. Math.pow stands for power. And what we're doing is we're taking x and raising it to the n power. So if this were a and b instead of x and n, we would be taking a and raising it to the b power. So what we're doing is we're taking the old value of sum, which when n equals 0, the old value of sum is 0. We're taking the old value of sum, we're adding to it x to the n, okay, where x is equal to 0.5, and for the first n equals 0, then n equal 2, so we're going to take 0.5 to the 0 the first time we run through. 0.5 to the 0 is 1, so sum is equal to 0 plus 1. Then the second time through, we're taking 0.5 to the 1 power, which is 0.5. So we add then this to the old value of sum to get the new value of sum. Then we take x squared, which is 0.5 squared, and so on. So we've done this before in BASIC, so I hope you're getting some idea what this is all about. Now our second sum is going to be the sum for e to the x, which has the n factorial in it. This first sum here was for the 1 over 1 minus x sum. So here we're taking the old value of sum 2, which is 0. Okay, and we're taking math.power, so we're taking x to the n again. But this time it's x to the n divided by n fact. Okay, we begin with n fact equal to 1 because 0 factorial is 1. Then I'm going to print out the values of sum. Okay, the value for n, the count value of n that we have, and I'm going to print out what n factorial equals, which is printing out n fact. And then I'm printing out the value of sum 2. Now, the last thing I do before I finish this for loop is notice this statement right in here. I set n fact equal to n fact times n plus 1. So this is how I'm computing the factorial statement. I start off with n fact equal 1. When n is equal to 0, n plus 1 is equal to 1, so n fact still equals 1. Then, when n is equal to 1, n plus 1 is equal to 2. So n fact becomes 1 times 2. And then it's the old n fact, which will be 2. So that'll be 2 times 3, which is 6. Then the next times through it takes 6 times 4. Okay, so it's computing the n factorial that way. And it does it the very last thing inside the for loop. And if you just write it out, you'll see that is the right value of n factorial that I want to stick into this statement right in here for computing that sum 2. And then the last thing I do here is I print out done. So let's look at that statement here. I've already typed this in and compiled it and checked that it compiles. So, okay, yes, save it. Okay, compile completed, run. So here it's printing out all those statements. Now you can look at these statements. Remember, the first value is when n is equal to 0, and it computes the first value of sum. It has the count as n equals 0, n factorial is equal to 1, and the second sum 2, is equal to 1. Second time through the loop, okay, it prints out the first sum is equal to 1.5. Okay, the count is n equal 1, and factorial is equal to 1. Sum 2 is equal to 1.5, and sum is equal to 1.75, and so on. My suggestion is you go through and you verify the first few values on those to make sure that those values are the same thing that you get from these mathematical expressions. Okay. And at the end, I have my count is 20, so that's when I stop summing up here. Let me get these in here. So my first value, sum 1, count 0, n factorial is equal to 1, sum 2 is equal to 1, sum is equal to 1.5. So I print all of these things out, and that's what I want you to check. Now, I can't quite see it here, so let me pull this up. There we go. So the last value, sum 2, I get 1.6487, so on. So that should be e to the 1/2. And the value for sum should be 2. Sum should approach the value of 2, and the value of sum that I get, 1.99999. So that's pretty close to 2. So we can see that 20 terms in the sum gives us about what we want. Okay, so we start up here at n equals 0, computing them out, and go all the way down to n equal 20. So check this out and see, and you will see that well, I'm getting the values that I should be getting. Okay, until next time.